Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. The topic of this lecture is testing. There are following points about testing. First, software quality. And next, two types of testing, including non-execution-based testing, execution-based testing. And what should be tested? And finally, when does testing stop? First, software quality. Just as what we have mentioned before, that software is just like other concrete physical entities. It also has the issues of quality. As far as we know that some other concrete physical entities really have excellent quantities, such as television, such as computers, and so on, right? Well, but it's not the same with software. That means software is far from excellent. Well, the definition for quality, for the quality of software is just the extent to which software satisfies its specifications. So, to make sure that the software quality is better, what is needed to do is software quality assurance. Okay? It's also called SQA. We know that in software organization, there are always some people in charge of testing our SQA. For example, in some software organization, there are some SQA person or even an SQA department. Okay. Well, the important thing that we should understand about SQA department is that it should be management independent. That means the development team and the SQA team should be independent with each other. And each of the group should be led by different manager. Okay. So only in this way can SQA person work freely and better. Okay, so let's imagine if the development members and the SQA members are in the same group, what will happen when they are working together? Okay. We understand that development is instructive, okay, while testing and SQA is destructive. So that means the SQA person are supposed to find as many bugs as possible for the product that developed by the development members. So you can imagine that as with time going on, and the people of the department team and the SQA person will unsatisfied or unhappy with each other. So surely this is not good for work. So that's why they should be management independent. We should understand that there are two types of testing. Maybe when we talk about testing, you will think about testing the code, testing the program. Well, that's true, but it is only one type of testing. It's called exclusion-based testing. And we understand that only code can execute. So the object of exclusion-based testing is just code. And we should never forget that there are one more type of testing, non-execution-based testing. Both the documents and the code are supposed to be tested for non-execution-based testing. Well, surely no document can execute, but handle documents, okay, such as documents for requirements, for analysis, for design, for integration, and so on. All such kind of documents need testing to make sure that they are proper. So it is quite easy to understand that document needs non-execution-based testing. Well, how about code? Execution-based testing for code is not enough, okay? Because some serious errors can be tested before running, actually. So it is a good solution that the code should be tested by some experts. That means by someone who is super than the programmers, okay, for the code. As we know that some code will have complex logic or complex algorithm inside, so it will be much better to have it tested before running by some experts. So that means non-exclusion-based testing. Actually, that is also very important for code. Okay, so these are the two types of testing. Well, we must understand that we cannot or we should not review our own work. It should be group synergy. What does it mean? Well, we must admit that every one of us have some blind spots. So that means it will be very difficult for us to find the faults in our own work, right? But sometimes it will be much easier for others to find out the faults in our work. So we must remember that we should never review our own work for non-exclusion-based testing. Actually, there are two ways for non-exclusion-based testing. Okay? The first is walkthroughs, and the second is inspections. Well, these two methods are quite easy to understand. They are assigned to you to study by yourself after classes. Okay. Next, exclusion-based testing. I'm sure that all of you has done some exclusion-based testing for your own code. You have studied quite some computer languages, such as C language or C++, Java, and so on. And surely, everyone will test its own program after programming, after coding. Okay, so someone will have such a concept. Okay, testing is demonstration that faults are not present. Do you agree with this statement or not? Actually, it is a nonsensical statement. Why? Because a successful test should find a fault, at least. So that means testing is just trying to find fault, not to demonstrate that there are no faults. Okay? Well, the formal definition for exclusion-based testing is this. It is the process of inferring certain behavioral properties of product based, in part on results of executing product in no environment with selected inputs. Well, actually, we must understand that there are 3 points in this definition. Point 1, inference. Point 2, no environment. And point 3, selected inputs. So from the word of inference, we should understand that the testing is not demonstration. It's just an inference. And we should also admit that testing is under some no environment. So that means you can only prove that the product in this way under this certain no environment. But we cannot demonstrate and we have no idea what will happen under other environment and selected inputs. We must understand that testing is just with some known and selected inputs. Okay? We cannot cover all kinds of inputs. So you can understand that actually exclusion-based testing is just inferior. And the next point, what should be tested? All of us has tested our own code. And just try to remember, what have you been trying to test it for your code? Well, I believe the first point that you would like to point it out is correctness. And the next, utility, reliability, robustness, and performance. Okay, first, correctness. The product is correct if input that satisfies the input specifications is provided. Okay. And the product is given all the resources it needs. And the output satisfies the output specifications. So if all these three are satisfied, and then we can say that the product is correct. So surely, the first thing that a software product should guarantee is that it is correct. We cannot imagine that the output is wrong, right? Yeah, okay. So the first point, correctness. Okay, the next point, utility. Utility means how the software meets users' needs. We should understand that all kinds of software are trying to solve some problems for the users. Well, how does the software satisfy or meet the user's needs? We can judge from the following aspects, okay, including ease of use and the useful functions and the cost effectiveness. We should understand that no user would like the software that is hard to learn to use. So just try to remember the software that we have used, such as Word, okay, or PPT, or Explorers, and so on. How is it? We must admit that it's quite easy to use, and it's also quite easy to learn, right? Okay, so only in this way the software can be popular. So the ease of use. And next, useful functions. We cannot imagine that a software will be welcomed by the users if it provides less useful functions and more unuseful functions, right? Okay. So that means the software should be useful for the users to the greatest degree. Okay. And the last, cost effectiveness. Okay. What's meaning cost effectiveness? We understand that the software is developed or is supposed to develop for some users, for some clients. And the different clients have different requirements for the target software. For example, a library management system. Maybe a college needs a library management system, okay? And a university will need a library management system. Okay? Maybe a city or a province also has its own library, and that libraries will also need some management systems. So can you imagine that all these library management systems will have the same requirements from the client? No, surely not. Okay, so let's say the libraries of a city or a province will have many users. So let's imagine the libraries of some university. Okay? There will be less users, right? Only staff and the students. And let's imagine the libraries for colleges. Okay? That means the user will only be the staffs and the students of the college. So the size are different, okay? And surely the requirements for performance or for user acceptance and so on are different. So that means that software systems will need different hardware environment or different operating system or different servers, different database, and so on to guarantee a sound performance. And surely, maybe a college wants a free library management system. That means maybe they want a free database and so on. Well, a university can afford more, right? So maybe they can afford a better server or better database. So How about the libraries for city or for province? Well, maybe they have more funds, so that means they can afford for a much better server or a much better database and so on. So that means the targeted software should consider about the cost for the client and users. So we must consider about the cost effectiveness. Okay, the third, reliability. Reliability means the frequency and the qualities of failure. In more detail, it means the mean time between failures and the mean time to repair and the mean time cost to repair results of failure. For example, all of us has used the ATM systems of the bank. So how many times have you found or have you encountered failure of the ATM system? And how about the mean time to repair? Okay, and take another example. The website or the homepage of our University of Northeastern University. How many times have you found it down? Okay, and how long does it take to repair it? Okay, so such kind of issues are called reliability. So of course, the stronger reliability, the better. And the fourth, robustness. That means the range of operating conditions and the possibilities of unacceptable results with valid input and the effect of invalid input. Let's say one software system can run only on Windows, while another software system can run on both Windows and Linux. So surely, the latter has a better robustness. Let's take again the example of ATM system. Let's imagine what will happen if you give valid input but you get something wrong. I mean, the system just gives some unacceptable results. That means it fails, or the program just terminates and so on. How often is it? Of course, the less the better. And the effectiveness of invalid input. So just imagine that you are using the ATM systems, okay? And you give some invalid input by mistake. What do you think the ATM system should happen? Should it just terminate, or should it just turn down? And we understand that the ATM system is quite robust. It won't just collapse with invalid input. Actually, what happens is that the ATM system will just go back to the home page, the welcome page. Okay? And then what you are supposed to do is just operate again. Okay? You just insert a card, okay, and do what you want again. Okay? It's okay, the system is not down. It's quite robust. Number 5, performance. Performance of a software means the extent to which space and time constraints are met, okay? Especially for real-time software. Okay? For example, our university, Northeastern University, has its own website. Well, there must be an extent to which, okay, the website can accept how many users, right? Okay, and how fast will it respond, and so on, right? Okay. Well, let's imagine the website of Soho, or Baidu, or Google, and so on. We know that many people just visit the website every day, anytime, so often. So the performance of such kind of website will be very important. Actually, we seldom have got the experience that the Baidu website or Google website or Soho website cannot accept it, right? Okay, so we can say that that has a very good performance, right? Okay, so all of these are what should be tested for exclusion-based testing. Well, okay, the next point is who performs exclusion-based testing? The first thing that we should understand about the exclusion-based testing is destructive. So that means testing is try to destruct the software system, try to find its shortcomings, try to find its bugs, errors. Okay? So the programmers cannot do the formal exclusion-based testing. That means programmers can only do informal testing. Maybe just test its correctness and so on. Informal, okay, without plan. And the SQL person should do the systematic testing. That means the formal testing. It should be under plan. And we should understand that testing should have its own plan. It's called testing plan. And that means that the SQL person should do some document about the testing plan. After the SQL person finds some bugs or finds some errors inside the program, programmers should debug the module. Because it is the programmer who has coded the program and he is familiar with the code, so he is the suitable person to debug the modules. Okay. As for the formal testing, all the test cases, that means the test plan are composed of test cases. And all these test cases should be or must be planned beforehand, including expected output. And then the testing person know whether the output is the same with the expected output or not. If it's the same, and then it is correct. Okay? Otherwise, there must be something wrong. And we should always remember that the test cases, that means the test plan should be retained afterward. Well, the reason for the testing case to be retained afterwards is for regression testing later, which will happen in the phase of maintenance. Regression testing. Okay. Okay, regression testing. Okay. Regression testing will happen in the phase of maintenance. Okay. From previous lecture, we have understand that in the phase of maintenance, we'll do some correctness, okay, or perfectio, and so on. Okay. And then after these changes, our code should be tested again, not only for the new functionality, but also for the old functions, to make sure that the changes doesn't affect the existing and the good functions. Okay, so next, when can testing stop? Just as what we have understand that just during the process of development, we understand that requirements, analysis phase, design phase, and implementation, and maintenance, all of these phases will need testing. Okay? Surely the products of requirements, analysis, and design are documents. And all these documents will need non-exclusion-based testing. Okay, and the output of the product of implementation and the integration phase will be code. And the code also needs both exclusion-based testing and non-exclusion-based testing. Okay, and the next phase is maintenance. And just now we have mentioned that during the phase of maintenance, regression testing will be needed. Okay, so that means as far as the software system is used by the users or is developed by the developers, it will be need tested. So testing will last until the product is irrevocably retired. That means only when the users and the client decided that the software system just stop serving, will be moved out of service, and then testing can stop. Okay, that means no need Okay, no need for testing. Okay, well, so much for testing. Well, testing is also a complex topic. There is quite some to study for testing. And we have understand that testing is very important for software quality. So actually, you will have one more course named testing later to study testing deeper. Well, okay, so much for this point. Okay, thank you.